Okay, graphing functions. Anytime we have x to the second power, we know that makes a u. Now, a reason why that does, you don't have to write this down, but if I take a bunch of numbers, let's say 1 to the second, 0 to the second, negative 1 to the second, that's 1 times 1, that's 0 times 0, that's negative 1 times negative 1. Well, that's 1, that's 0. Negative 1 times 1 is positive 1. So as you can see, it makes a u. It would start, go low, high. So it's a u, so we need to find the 3 coordinates, and this is my vertex right here in the middle. So x, y, x, y, x, y. So to find the vertex, it depends what form it's in. This is ABC, AHK, APQ. Well, if I don't have any parentheses, then it's A, B, C. Okay, so opposite of B divided by 2 times A finds the vertex. Okay, so the opposite of B is negative 12. Then 2 times negative 3 is negative 6. So then I divide those, I get 2. So then I take 2 plus and minus 1. So 2 plus 1 is 3, 2 minus 1 is 1. Then we substitute those numbers in for x. Okay. So negative 3 times 3 to the second plus 12, and then 3 minus 5, I get 4. Then I input the 2, and the output's going to be 7. Now I input 1, and the output should be back to 4. So it is. So I go 3, 4. This is x, this is y. So 1, 2, 3, 1, 2, 3, 4. 2, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. Then 1, 4. 1, 2, 3, 4. Okay, so that parabola opens downward, which is expected with the A negative. Now you label 2, 7. And then you use that to identify your domain and your range. So domain's x, range is y. So 2, 7. Well, if I check out the 2, I'm higher and lower than 2. So that means all for the domain. But I check out the 7, and I'm only lower than 7. So I put the 7 down, and then now these numbers here, these 4s, they're the same. They're less than 7. So we need to eat the 7. 7's bigger than 4, so we would eat the 7. That means 7's bigger than any y on this graph. Okay? Okay, next one. Y equals negative 2 times the quantity x plus 2 to the second power plus 3. Okay, so there's x to the second. It makes a u again, so there's going to be 3 coordinates we need to find. But this one's a little bit different form. This is still my vertex. Now, this is not ABC standard, this is AHK vertex. Look at it. So your A value is negative 2, the H is positive 2, and the K is 3. So to find the vertex, it's easy. You just take the opposite of whatever H is. So the opposite of positive 2 is negative 2. Then we take the negative 2 and we add and subtract 1. So negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. Then we substitute those values. So you take negative 2, then negative 1 plus 2 to the second, and then plus 3. Now, negative 1 plus 2 is 1. 1 to the second would still keep that at 1. And then 2 times 1 is 2, plus 3 is, or excuse me, negative 2 times 1 is negative 2, plus 3 is 1. Okay, now I'm going to substitute negative 2. I guarantee you're going to get the K. Okay, so 3, just like I thought, and then negative 3. So that's 1. So negative 1, 1. Negative 2, 3. Negative 3, 1. I did that one wrong. I missed that one. Okay, so please label your vertex. Your vertex is negative 2, 3. So then x, y. So -2, but you're higher and lower, so the x is all for the domain. All numbers are covered in the domain. They are not all covered in the range. Because, yeah, you got this 3, but these numbers then are less than 3. 3 is bigger than 1, right? So it needs to eat the 3. Okay? So that means 3 is the highest. You have to eat the highest. If it's a high point, you eat that number. If it's a low point, you don't eat it. Okay, next problem. 4 times the quantity x plus 3 times the quantity x minus 5. Okay, so two quantities involving x multiplied means it's a u, okay? So I know I need the 3 points, with the middle being the vertex. But this, when there's two quantities involving x, it's an APQ form, that is known as factored form. This is a little bit different, okay? You take opposite of P and opposite of Q for these top two, okay? You actually find your vertex is the last thing you fill in. So opposite of positive 3 is -3. The opposite of -5 is +5. Now, the thing is, putting a -3 in for that x there will give this 0 value. And then if I'm multiplying 3 things, but one of them 0, then the product's 0. And then putting a 5 in makes that 0. And then it'll be 0. So 1, 2, 3, 1, 2, 3, 4, 5. So the vertex has got to be halfway in between the x-intercepts. So to find the halfway point, we need to add and divide by 2. So -3 plus 5 is 2. 2 divided by 2 is 1. Now I substitute 1 into the equation for x, okay? And I get -64. We're going to have to go by tens to hit that. Now you go negative, okay? This is the y, this is the x. Now, this is your 0, so now -64 is below the 0. So 1, -64, okay? All right, then label the vertex, and that's going to be 1, -64, okay? So the domain and range, remember domain is the values for x, range is for y. Okay, so you got this 1 here, but you're higher and lower again, so that's all. The range, -64, okay, so I put that down. Now 0 is bigger than -64, so these numbers are larger than -64. So we don't eat the -64, we're going to eat the y, because y's got the bigger value. Okay, now in this one, there's no second power, okay? Nowhere to be found, so that's a line, okay? Writing something that you hopefully have now, okay? So, line, get y by itself if it's not already, it already is, so then MB that. And then slope y-intercept. So the slope is -2/1, and the y-intercept is +5. So 1, 2, 3, 4, 5, then down 2, forward 1. And it's a line, lines, domain, and range. No. You don't do a domain range on a line. Now it's equation solving time, okay? Now, when you solve an equation, you got to list what you have for variables. You have x second and you have x. So same variable, 2 different degrees. So that's got to be the factoring properties. So there's 2 answers. Now in factoring properties, you want to make sure you're equal to 0, which you are. Now you count the number of terms, 2, 3, or 4. There's the setups for the different ones. So this is 2, so it'd be a binomial, so I do GCF, then I see if we have a difference of perfect squares. Okay, now x on the end, you bet. No negative in the front, then 16 and 80 are in 16's row. So it'd be 16x is the GCF. So then I go divide by 16x. 16 divided by 16 is 1. X second divided by x, I get a cancellation there. 80 divided by 16 is 5, and then x divided by x is a cancellation. It's actually 1, but 5 times 1 would be 5. Okay, now, positive, positive, so it's not even a difference. So you put no, and you put the 1x plus 5 right next to that, equals 0. So F1, F2. So 16x equals 0, 1x plus 5 equals 0. So divide by 16 and you get 0. You can take out the times 1, you just subtract 5, and that's negative 5. Okay. Next problem, x to the second power minus 3x minus 28 equals 0. So I have an x second and an x again. So again, we're applying the factoring properties. Same variable, 2 different degrees. So there's 2 answers. The zero's there, but this time we have 3 terms. It's a trinomial. So GCF, then I go to my table. Okay, no x, no negative, 1, 3, and 28 is 1. So 1 times negative 28 is negative 28, so it's a mismatch. Positive, negative, and it's got to add to negative 3. 1 and 28, that's negative 27. Doesn't work, that's too wide. 28 divided by 2 is 14, that's negative 12, that's too wide. 3 is a decimal. 28 divided by 4 is 7. And I believe that is your negative 3. You're right on the mark. Okay. So, put in those parentheses. Positive 4, negative 7. Now, a is 1x to the second. So, x times x. And then I put my 1 in front. Okay, so 1 and 4 can only really be divided by 1. 1 and 7 only by 1, so that'll stay the same, and that'll stay the same. So 1x plus 4 times 1x minus 7 equals 0. F1, F2. Okay, multiplication by 1 is not needed. You subtract 4 and you get negative 4. Multiplication by 1 not needed. You would add 7 and you get to 7. Okay. Next problem. We got x to the third power minus 5x to the second power minus 49x plus 245. I'm going to help you out on this one. This one's kind of a cheap one. You got x third, x second, and x. You have to use factoring properties. There's 3 answers. Okay. So the zero's there, but now you have 4 terms. So that's the grouping and then the difference of perfect squares. So I set up the grouping. Then the GCF lines. Okay, you've seen it before, it's right there. Okay, the same thing with GCF, little GCF lines. Then little parentheses, big parentheses, and then we got to check that big parentheses for a difference of perfect squares. Okay, so we have 1x to the third minus 5x to the second, and then you got the negative 49x plus a 245. Okay, so x second, no negative, 1 and 5 is 1. Now the problem is here. There's no x, there would be a negative, but yeah, that's going to be hard to tell since I don't even have 49. See if you can divide them both by 49. Well, 49 divides by itself, it's 1. 245 divided by 49. So let's use 49, it'd be 49. Okay, so I'm going to divide by 1x to the second here. And I'm going to divide by negative 49 here. So it's 1x third divided by x to the second. is a cancel, giving me a remainder x. And then negative 5. And then x second divided by itself is a complete cancel. It means it would be 1. But then negative 5 times 1 is just negative 5. That's going to be 1x minus 5. So we have 1x minus 5 within each of the quantities. And then we put the 1x to the second minus the 49. Now take those 1's off the front of the x's, and over here we're just going to put x minus 5. Now we have positive, negative, so that's the difference. And are these perfect squares? Well, yeah, x second's x times x, and 49 is 7 times 7. So you replace this with this. So x plus 7, x minus 7. Okay. So x minus 5 could equal 0. X plus 7 could equal 0. X minus 7 could equal 0. So we add 5 and we get 5. We subtract 7 and we get negative 7. And we get plus 7 and we get positive 7. Okay. Number 4, 6x to the second power minus 13x minus 5 equals 0. So we have x to the second and we have x. So again, we are using factoring properties. So there would be two solutions here. 0's there, check it. Okay. And x on the end, nope. Negative in front, nope. Or shoot, there's 3 terms. I'm ahead of myself. So GCF table. X, no. Negative, no. 6, 13, and 5 is just in the 1 row. 6 times negative 5 is negative 30, so that's a mismatch. The two factors, you got to have a positive multiplied by a negative to find two factors of negative 30. Now those factors have to add to negative 13. So 30 divided by 1 is 30. That's negative 29. That's too narrow. Okay. 30 divided by 2 is 15. That adds to, there's my negative 13 right there. You don't quit dividing until you're either too narrow or you repeat yourself. Or if it's up above 100, I'm not even going to make you do that. So A is 6x to the second. So you got a positive 2 and negative 15. Now x times x, and then we apply the coefficient of 6 in front of the x's. Now 6 and 2 can be divided by 2, and then 6 and 15 can be divisible by 3. So it's going to give you 3x plus 1, and that's 2x minus 5. So check this. 3 times 2 is 6. Bingo. 1 times negative 5 is negative 5. Bingo. So we have 3x plus 1 times 2x minus 5 equals 0. So F1, F2. So 3x plus 1 could equal 0, or 2x minus 5 could equal 0. So I subtract 1, I get negative 1. Negative 1 divided by 3 is one of those crazy decimals that just goes on, so just keep it negative 1 over 3. Now, I'm not against decimals, as you're about to see here, because 5 divided by 2 is 2.5. That's not a crazy decimal. That's just a simple terminating, ending decimal, and there we have it. Okay, number 5. This is going to be a quick one here. Negative 2x to the second plus 3 equals negative 13. You have x second only, okay? You only have 1 degree of x, so you need to be using linear properties to solve this in the most efficient way possible. So linear properties, you figure out how many answers are. Well, there's 2 because the variable's to the second. Collect the x terms if you have more than 1. That's a non-issue. Then you solve, okay? So you subtract your 3 and you get negative 16. By the way, solve means do this. Get rid of the plus by minus 3. You just do inverse operations. Get rid of your times -2 by dividing by -2, and then you get rid of the second power with the square root. So I subtract 3. Then I divide by -2. And then I do this, find the square root of 8. So x equals positive negative. And the square root of 8 is 2.83. Could also be negative though. Okay, next problem. 9x squared plus 10x plus 2 equals 0. So you've got x to the second and you've got x, so again you have to apply the factoring properties. So there's two answers. Okay. And 0, to run factoring properties you need the 0, and you have 3 terms, so that's GCF table. So no x, no negative. 9, 10, and 2 is just in 1's row. Okay. Then 9 times 2 is 18, positive, so the signs would have to match. They have to add to positive 10. 18 divided by 1 is 18. Now that's negative 19, that's too wide. 18 divided by 2 is 9, that's negative 11, you're still too wide. 18 divided by 3 is 6, that's negative 9, now you're too narrow. Now stop dividing and you go to the quadratic formula. So, opposite of b, plus or minus d square root, b squared minus 4ac, b squared minus 4ac over 2a. Over 2a. So the opposite of b is negative 10. B to the second is 10, 4a is 9, c is 2, and then a on the bottom is 9. Okay, so we're going to have a negative 10. 2 times 9 is 18. Now we have to figure out what's this square root. So 10 to the second minus 4, 9, 2. So I got 28. Positive, negative, and then the square root of the number 28 gives me 5.29. Okay, so we take negative 10 plus 5.29, click equals. Before dividing by 18, I get negative 0.26. Then I take negative 10 minus 5.29, click equals, dividing by 18, negative 0.85. Okay, last page. Now we have a couple parentheses. Now if I have a parentheses, I put what's inside it, x plus 7 with the power. Well, there's two answers, but that power means you're blocked. You cannot distribute. You have to use h to the second, okay? So get that out of there, replace it with h. Now, you got to remember that you're going to be bringing back the x plus 7, and you're going to bring it back twice. Because we replace this with h, it's going to have 4 to the second plus 6 equals 20. Okay, so the reason we're going to have two sides is because to get this h by itself, we need to minus 6, and then we need to divide by 4, but then that second power we need to do the square root, which results in a positive, negative, the same thing. So we subtract 6, and that's 14. Okay, then I'm going to divide by 4, and that takes us to 3.5, and you can square root a decimal. As long as it's a positive, you can square root it. So I find the square root of 3.5. Okay, 1.87, but that could be positive or negative. So I put, those aren't your answers. Those are what h equals. That's what the x plus 7 equals. So you put 1.87, negative 1.87, and you solve it. So you subtract 7. 1.87 minus 7 is going to be negative 5.13. That's going to be negative 8.87. Okay, next one. Now, it looks like the same thing, but x plus 7 does not have that power, so we are not blocked. We just do we just distribute. Now, there's one answer, so distribute. That means with your rainbows. So 4 times 1x is 4x, 4 times 7 is 28, and then you got the plus 6 equals 20. Now, first off, you got multiplication by 4. You need to combine these. Just put add. That's 34. So you got 4 times x plus 34 equals 20. Or you can just subtract them one at a time, but it'd make more sense to me to combine them first. So we're going to minus 34, and then we're going to divide by 4, but we are not doing the square root now. So that's going to be negative 14. And then I divide by 4, and that's going to be negative 3.5. Okay, now story problem time. A projectile is launched from a height of 10 feet with a velocity of 112 feet per second. After how many seconds would one expect it to land on the ground? Okay, so I'm finding the seconds. So seconds I define with a variable, but also feet, it's related to feet. So x is seconds, y is feet. Now the rate of change between the two variables is 112 feet per second. And this goes up and down by the force of gravity. So no table is required. I just make a parabola going up and down. So you started at 10 feet and you ended at 0 feet. My job is to find how many seconds are with the 0 feet. Okay, I don't need to have question mark seconds there. I know that's 0 seconds. Okay, I'm interested in the 0. So the equation, anytime I have that parabola, you need an x to the second, an x, and a constant, or at least that's what you have to look for. So gravity is negative 16. 112 is your velocity, and then you take this 10 feet and put it in the constant. And then again, y is the feet, the height. Okay, 0 feet goes into the equation, and it's going to be going in for y. So remove your y and put 0 in. And now you have to solve for x. Question mark seconds means you're solving for the x. So you have x second and x to the first, so you have to use your factoring properties. Okay, so 0's there. 3 terms, so GCF. And table. Okay. So no x, there is a negative. Now 16, 112, and 10. So let's look at 10. Now 10 wouldn't work. 16's not there. No, it wouldn't be 5. Now you see 10 and 16 and 2, but then the table runs out before I get to 112. So we're looking at the 2 row. So take all those numbers divided by 2, and if there's no decimals, we're using 2. Okay, I didn't get a decimal, so that gives me the green light to put 2 there. They're all divisible by 2, but it's got to be negative 2. So that's positive 8x second. 112 divided by negative 2 is negative 56 x, and then negative 5. So you can put your negative 2 out there. Now 8 times negative 5 is negative 40. So that's a negative, so that's a mismatch. It's over. Add to negative 56. Now 40 divided by 1 is 40. Well, that's negative 39. That's already, see, if you go 1 plus negative 40, you're already too small, okay? You're already at too narrow of a gap, okay? So you put QF. So opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So opposite of B is positive 56, and then negative 56 to the second, then A is 8, C is negative 5. A on the bottom's 8. so you don't need that. So you put 56 in front, 2 times 8 is 16. Then I find the inside of the square root. So negative 56 to the second power minus 4, 8, negative 5. And that's 3,296. So the square root of 3296 is 57.41. So we will take 56 plus 57.41, click equals, divide by 16, and you get 7.09. Then 56 minus 57.41, click equals, and you divide by 16, and you get negative 0.09. So 7.09 is a number of seconds that go with 0 feet. The negative is garbage. Okay, next problem. A rectangular garden measures 15 feet by 20 feet. A walkway forms a uniform border around the outside. The garden and its walkway can occupy a space of 546 square feet. How many feet wide is a garden? Now we're talking about a shape, and we have the dimensions. Don't put LW, you put 15 and 20 because you know the length and width, but you're building a border, so you recalibrate the dimensions. So we know we got 15 in the middle, 20 in the middle. Now these all are unknown, but they're the same all the way around, and that's the answer to the problem, those X's, okay? So with a shape, we're going like this, and they give us this area here. That's your area. So we write an equation for the area. So it's two quantities, one for the length, one for the width. So the length, 2x plus 15, because x is 2x, not x second. I'm adding the x's. Adding the x's doesn't change the power. That's 2x plus 20. With the area being 546. Now we need to FOIL before we solve the equation. So 2x times 2x, 2x times 20. Then 15 times 2x, 15 times 20. 4x second, 40x, 30x, and 300. Now simplify that product. So you got 4, 40 plus 30, 70, and then 300. Now take that product over here. And it's equal to the 546. So the equation for x, now I can solve it. It's got x second with x, so you have to apply your factoring properties. So there's two answers. But factoring properties, you need the 0 to go here. So you're going to subtract 546, and that goes quite nicely with 300. So you have 470. And then the 300 minus the 546 is negative 246. Okay, so now we see that there's a trinomial, so GCF table. X second, x, and constant. Okay, I'm not seeing the x, not seeing the negative, nice, so no x, no negative. Now 4, 70's not in 4's row. Now 4, then the table runs out before I find the other two numbers. So in the second row I see 4, but then in that row we run out of room. So take that 2 that I'm looking at and divide all these by 2. And if you don't get any decimals, then that's the green light to put 2. No decimal and no decimal. So they all are divisible by 2. So if you run out of room, you take the row you're looking at, divide all those numbers by that row's value, okay, the row's multiples. So then you divide by 2, and you get 2x to the second plus 35x, negative 123, okay. All right, so bring your 2 over. Okay, 2 times negative 123 is negative 246. That's well over 100. I put QF. So opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So negative 35, B is 35, A is 2, C is negative 123, and A on the bottom's 2. So you got negative 35 in front. 2 times 2 is 4. Now I got to find what the square root equals. So I evaluate the inside. Okay, I got 2,209. Now I find the square root of that. I got 47. Okay, so it's an integer. That's fine. That means the t-chart would have worked, but it would have taken forever. Divide by 4, and that's 3. That's why it's over 100. I'll let you just go to the quadratic formula. Then you minus, divide by 4. Negative 20.5, so 3 is the legit answer. Okay, and finally the last problem. An electronics store sells about 70 of a new model of digital camera at a price of $320 each. For each $20 decrease in price, about 5 more cameras are sold. Find how the store can maximize revenue. Now, when you're finding the maximum, you're finding the vertex. So if you go look on that graph, vertex is opposite of B divided by 2 times A, because we're going to write an equation that's very similar to that. Okay? So I'm going to write opposite of B divided by 2 times A. So if I'm finding the vertex, I know exactly what I'm finding, so I don't waste time with boxes and unit analysis. Okay? You need a coordinate, and the x will be found with opposite of B divided by 2 times A, same as it was here. And then when I get that value, I'll just put it into the equation. But I obviously need an equation. So we know we're going to have an x to the second, and x, a constant, equals y. Okay, so y stands for revenue. It does not stand for height, so you can't just throw in the negative 16 and all that. This is not height. There's no gravity. So revenue, you make 2 quantities. One for the money I'm charging, one for the items. Now you have a money amount, but it changes. You have an items amount, but it changes. So to find out how to fill out those parentheses, make a little table for your money and items. So the money, you got 320 with 70. Then what are we doing to the money? $20 decrease. That would mean minus 20. Well, if that's decreasing, then that's going to increase. So 320 minus 20 is 300. 70 plus 5 is 75. And then you get to 280, and then 80, and then it goes on. So the money starts at 320. The items start at 70. Okay? Then what are you doing to the money? You're decreasing it by 20. 20 times x. What are you doing to the items? You're increasing it by 5. 5 times x. So, FOIL method. So 320 times 70. 320 times 5x, negative 20x times 70. You got to remember that 20x is negative. And then negative 20x times 5x. So 320 times 70. It's going to give you 22,400. And this is going to be 1,600. X, and this is going to be x, this is going to be negative 1,400, negative, then you're going to have x second, and this times this is negative 100. So you have negative 100 for your x to the second, that's your A, and then you add those, that's 200, that's your B. Then your C is 22,400, but I don't really use the C label because I just need the opposite of B and the 2 times A. So the opposite of B is negative 200. 2 times negative 100 is negative 200. Then we divide, and it's 1. Okay? So then we substitute 1 in for x. And that will find our y. Okay? So we got negative 100 times 1 to the second plus 200 times 1 plus 22,400, and that's 22,500. So what that means is you only have to change the price one time to make your maximum revenue 22,000.